Okay, it is day 2 time. All right, day 2. I got it. I just did it. Thank you for reminding me, though. Okay, day 1, day 2. Here's day 1. Day 1 would be this. And day 2, which is what we're doing right now, would be something like that, right there. Okay, so what's day 1? Exponential equations, right? So exponential was Friday. Okay, now here comes day 2. Day 2 will be what kind of equations? Log equations. I mean, if it says the word log, a log of x, you're going to have a log equation. So this is what you're solving today. You may know the answer to x. Log of, you think x is 2? Remember what base this is? What base am I in right here? I'm in 10, right? 10 to the what power? Second equals what number?
100.
That number right there. Well, what's 10 squared? 100. X is 100. I solved it for you right now. All I did is I looked at the base. 10 to the second is 100. X is 100. That's how easy log equations are. But, of course, they get much harder than that. Okay, so let's try this. Let's go here, right there, I guess. It says the log equation. A log equation is an equation that includes one or more what? Oh, I didn't want that. Sorry. Can you understand that? Logs. Okay, a log equation is an equation that includes one or more logs, including a variable like this. Log of x. Not sure. There. Log of x is what I wanted to say. So if you see log of x, you have a log equation. Now log equations with a logarithm on one side of the equation, and that's what's coming right now. And how do we solve these types of equations? It says right here, when you have a logarithm on one side of the equation, change it to what form? What would be the other form? Exponential. Yep. So here's what you want to do. Every time you see a log equation, don't try to solve it. First, convert it to what? Exponential. And then once you convert it to exponential, just solve it. So here's your first one. Okay. What's the log of this number? 3 minus 2x and set equal to negative 1. Well, first of all, you have how many logs here? How many logs are you counting? Just one. There's just one log here. These are so easy because all you do is put them in exponential form. Exponential. I spelled that totally wrong. Sorry. Exponential. There. Form. Okay, so let's get this in exponential form. What base am I in? 10, isn't it? Don't see a number, it's 10. So here we go. Exponential form would be 10 to the what? 10 to the negative 1 equals? This number, whatever number you took the log of. Well, that'd be 3 minus what? 3 minus 2x. Okay, well, first of all, what's 10 to the negative 1? 1 over 10 to the positive 1, right? 1/10 equals 3 minus 2x. Now guys, 1/10, if you want to, just call it a decimal. What's the decimal? 0.1. So, okay, what's the first thing you're going to do to solve for x? Subtract 3. 1/10 subtract 3 is, what do I have left here? Negative 2x equals what? Negative 2.9. Okay. Or you could say a fraction like Ethan said, 9/10. Now what? Divide by -2. When you divide by -2, you get positive 1.45. There you go. Right? How would you know you're right? Take your calculator, put it in. Log, parentheses, 3 minus 2 times 1.45, parentheses, hit equals, you better get -1. If you don't get -1, you did it wrong. Get it wrong. Good? So what's the secret when you see one log? Change it to exponential form. Okay. Hey, do you have one log or 2 logs? One log, change it right now. Change to exponential. Go. Okay, are you that far? Take the base 10, raise it to the second power. 10 squared equals 5x plus 2. 10 squared is what? 100. 100 equals 5x plus 2. Say it, just say it. Minus 2, then divide by 5. Minus 2, divide by 5. Minus 2. I get 98 equals 5x. X equals, after you divide by 5, what? 19.6. Okay. And here's me thinking, oh, how easy is this just to do? Punch this into my calculator. Log, parentheses, 5 times 19.6 plus 2, parentheses, equals 2. I mean, it's that easy. And you guys are taking quizzes and tests. You should be punching these in to make sure you're right. Okay? Okay. Now, these first 2 problems were nice because how many logs did you count in your equation? You counted 1 log, and it says when you have basically one log on one side of the equation, change it to exponential form. That's really all you have to do. If you come down here, though, what's different? And I got 2 logs. So if it's easy to solve when it's 1 log, how do we make 2 logs back to 1 log? What? Multiply, divide, but you're saying what? Properties, which means what you're saying. So basically, if you take Thursday last week, we talked properties. If you see log, subtract, log, you can take 2 logs and make it 1 single log, as long as you do what? Subtraction goes with division. So just make log of this number. What divided by what? 6 on top, over 3x on the bottom. Yep. Okay. Well, 6 divided by 3x is what?
2x.
Oh, not 2x. You're close when you said 2x. It's not 2x, is it? Isn't it? 3 goes into 3 once. 3 goes in here twice. Isn't it 2 over x?
Oh.
Yeah? So 6 divided by 3x is 2 over x, right? Okay. Now you're down to that point again. Hey, I got 1 log. I can just convert it to what? Exponential. 10 to what power? 10 to the -2 equals 2 over x. What is 10 to the -2? 1 over 100. Okay, yep. Hey, when you do negative exponents, just say this. 10 squared is 100, so 10 to the -2 has to be 1 over 100. I mean, that's the way I think of it, okay? Okay, here you go. You got this equation. How are you going to tackle this?
Multiply by 2.
Multiply by what? 2. You could multiply by 2. If you multiply by 2, you're going to get 1 over x equals. Multiply by what? X. You can multiply by x, okay. Does anybody remember, like, law of sine? Remember law of sine? Didn't we just cross multiply? These are just proportions, right? If you got a fraction equal to a fraction, can't you just cross multiply? I mean, you guys, what you're saying is good stuff. It's just like, can't you just do this? That's going to get you what? X. What's this going to get you? 200. Oh, look, I'm done. That's the answer. I mean, you can cross multiply. Now, Amber, you said multiply by x, and somebody over here said multiply by, I can't remember what you said. 2. You know, if you multiply by 2, you're going to end up with 4 over x and 2 over 100. I'm not sure if that helps much. Okay. I'd probably, Amber, if I did it your way, Amber, multiplying by x, oh, look at that color. What would you get? X's cancel out, right? You get 2 equals what? X times 1, well, 1 100th times x, and divide by 1 100th. Or multiply by the reciprocal, right? Huh? You like this better? Okay, do it. Do it that way. You didn't like my way? X equals 200, done? Okay. At least you're honest. All right. Good? So what was the secret when you had 2 logs? Properties. Properties is what you learned last Thursday. You only learned them so you could use them here. Okay? All right. Continue. Where are we at? Here we go. All right, again with the 2 logs, use your properties. Oh, by the way, I forgot to tell you, you could have checked your answer in the last problem, right? Log plus log, what are you going to do to them? It is multiplication. It's the same as 1 log, except multiply the 2 numbers, right? If you distribute this through once, twice, you end up with? Correct? Okay, now watch. When you did that distribution, you're still taking the log of this entire number, the entire number. How do you get this in exponential form? Tell me. 10 to the what? 10 to the first. So just 10 equals what? Yeah, all of this, right? Okay, there you go. The last period, we were lost. We were just lost here. What do you have in front of you? What is that? I know it's an equation, but tell me what kind of equation? Louder. You say quadrant? Quadratic. Quadratic, she said. And she's right. Last period, I could not get that out of them. This is quadratic because you have an x squared. How are you going to solve quadratics? You say it again. Set it equal to 0. And then do what? Factor it. Guys, you could factor this. You could do quadratic formula. You could complete the square. You could graph it. Find the x-intercepts. Or you could get x squared all by itself and then take the square of both sides. The problem with that method is you can only do that if this term is missing. And it's not missing. So here's me thinking, just factor. Move this over here, right? So it's going to read x squared what? Minus 3x it? Minus 10. Okay. Now go up here and do what? Factor. Factor it. Two binomials that give you this are x times x is x squared, right? Two numbers that give you negative 10 but add up to negative 3 are? Negative 5, 2. Okay. Negative 5. Do you mean positive 2? Yeah, okay. Everybody agree with that? Okay. Is that the answer then? No. When is this times this going to be 0? When this x is what? 5. And when this x is what? Negative 2. You okay with that? Okay, time out. Don't take off on me. Don't go to the next problem. You gotta look at this. If you check this number out, put a 5 in here, put a 5 in here. Is it gonna work? Yep. What's log of 5 minus 3? Isn't that log of 2? Log of 2 plus log of what? Log of 5, right? Okay, what's log of 2 plus log of 5? That would be log of 10. What's log of 10? 10 to the first, right? Yeah, it works. It works. 5 works. Try negative 2. If you put in negative 2, does it work? Why not? First of all, if you put negative 2 in this one, you're going to get log of what? Negative 2. Can you take the log of a negative number? No. We said this last week. You can't take the log of negative numbers. Is this truly a solution? No, this doesn't work. So here again, when you get 2 answers, it doesn't mean they always work. So check it. Good? Okay. Now go on. Now do this one. Oh, log minus log plus log. Get those 3 logs to become what? 1 log, yeah. Anybody want to tell me what you do with that 2? Yeah, this 2, I hope you did this. Make it the exponent, right? Log of x squared instead. Minus log of 5 plus log of 3.2. The first 2 logs are subtraction. That turns into what? Division. Good? All right. Now that I'm there, 2 logs added together is really the same as 1 log. One log what? If I add the log of this number plus the log of that number, it's the same as 1 single log, as long as I do what to these 2 numbers? Multiply 3.2 over 1 times this over this, which ends up being what? (3.2x squared) over 5 equals 3. Now you're down to 1 log. Turn it into exponential. Base 10. 10 to the what? What's 10 to the third? 1,000. 10 times 10 is 1,000. should equal what? This number right here. 3.2x squared over 5. Okay. Tell me what to do. Times 5, okay. I know you guys don't want me to do this because I already took my survey, but you guys, you gotta understand it's just a proportion, right? You can just cross multiply, you can. But your class doesn't seem to like that, I don't know why. So I'll just go like this. I'll take it times 5 like you said. 5s are out. Take it times 5, what do you get? 5,000 equals 3.2x squared. Divide by 3.2, what do you get? 1562.5. Okay. Square root of both sides? 0.5? Exact?
No.
Oh, you round it? Okay. But wait a minute. I thought you always bring in 2 answers, don't you? When you take the square root of both sides. But does negative 39 really work? And you know it doesn't work. Why? Yeah, right here. Look, right here. See that? If you take the log of negative 39, it's not going to work. So, okay, so we got to throw which one out? Throw the negative out. So the answer is just what? 39.5? Roughly, not exactly. Approximately 39.5. Okay, try that one. Log on the left, log on the right. What are we going to do? This does not look like what we just did. Who's got a guess? Nobody's going to guess? Oh, whoa. Sorry, say it again. The 1? Oh, okay, what do you want me to do? How do you just get rid of it? Like, when you want me to get rid of this? Okay, so Kayla's basically saying, I think, just get this log off this side and put it on that side. Is that okay? Because then if I have this log over there with that log, then I have 2 logs, and I'll just use my properties to get it down to 1 log. So how do you get rid of log of x minus 1? How would you do it? Okay. She's telling me to subtract this log. Is that okay? Hey guys, look at the 1. Look in between the 1 and the log of this number. There's a plus sign. This is addition. And because it's addition, I'm going to get rid of log of x minus 1 by subtracting log of x minus 1. Now this is out with this, right? Now you have what? 1. Over here you have what? Log of 4x plus 2 minus log of, over there, log of what? X minus 1. Now it looks just like the previous 2 problems. 2 logs being subtracted would be the same as? What? Division? So, what are we dividing here? On the top would be 4x plus 2. On the bottom would be x minus 1. Base what again? 10. 10 to the what? First equals this whole number, right? 4x plus 2 over x minus 1. Okay, I'm curious. What are you gonna do? Reduce. What do you mean? Three x. Oh, you're saying that this is 4x over x, so that's 3x. No. The only thing you can do here, I think, if you had something like this, 4x plus 2, if you had multiplication going on and you had like 2x plus 5, here you could cancel out the 4 and the 2. If you have multiplication going on, you don't have multiplication, you have addition over subtraction, you can't touch them. These are not reducible, okay? The only thing you could do is right here, 4x plus 2. If you wanted to try this, factor out a 2. If you factor out a 2, you get what? X plus 1. X plus 1, x minus 1 does not reduce. So there is no reducing here. Absolutely no reducing. Okay, so now what am I going to do to solve? What? Yeah, I would. Sorry. So that's 10 over 1 equals 4x plus 2 over x minus 1. I would cross multiply here. 1 times this is what? 4x plus 2. And then this is what? These two. 10x minus what? 10. Get the x's on one side, get the numbers on the other side, right? Subtract 4x, subtract 4x. 6x equals what? Get the minus 10 off this side. 12, because you're going to add 10, aren't you? Two. When you have logs, 2 logs, use your property to get to 1 log. When you have a log on the left and a log on the right, get all logs on one side, then use your properties to get it down to 1 log, then change it to exponent. And that should take care of it. Okay? All right, you have 12 minutes. Work. You guys seem very quiet today, super quiet. Hopefully it was sinking in there, right? Open that book and start your problems.